Hey kids, Smath here. I'll talk to you for a few minutes about indicators. Indicators are basically weak acids that have optical activity. That's a fancy way of saying they change colors between their acidified form, which is going to be over here on the left, acidified, and once we get past 7, between its basic form. Now that doesn't necessarily mean past 7, because you can see that alizarin yellow's acidified form lasts all the way up until it's up above pH of 10. Then it flips over to a basic form where it loses a proton. So the generic equation for these are weak acids, HIN, that basically go to H plus IN minus. And so a very common one that we're used to working with is towards the bottom here is phenolphthalein right there. And you can see that phenolphthalein changes somewhere right around 8.5 is our pH. And so what that means is we're going to have an HPTH, a phthalate ion, that goes to H plus a PTH ion minus. Okay, and this is the acidified form, and since this is a weak acid, we're going to expect this to have a Ka value, and I'm going to tell you that Ka value, it's not really coincidence, but I'll show you why. 3.16 times 10 to the negative 9th. Well, if all of a sudden this is a weak acid, and we put this into a Henderson-Hasselbalch, then we can say its pH is going to be equal to negative log 316 10 to the negative 9th plus log of PTH minus over HPTH, of course, concentrations. And we know that this works best when it's plus log of equal concentrations. So if we just look at the pKa here, the pKa is 8.5. plus a log, what we would like to be of 1. And that's how we select an indicator if we're given these, is we would select an indicator given off of its Ka values. Now, a lot of you are asking yourselves, well, what about thymol blue or cresol red that have two indicator ranges? Well, guess what? They're going to have 2 Kas. So thymol blue is a weak acid, and that's going to be H2TH, where it's going to go to H, TH minus plus H plus, and we're going to have Ka1, and that Ka1 is going to be somewhere down around 10 to the negative 3rd. It's 0.0031. which means my pKa is right where it changes at about 2.5. And then it has a second where it's going to take the H thymolide ion and dissociate that, -2 plus an H. That's going to have a Ka2 of 6.3 10 to the negative 9th, or a pKa of about 8.2. So what we can do is look at these indicators, look at our titration, see where the color change is going to occur, and pick an acid based on its pKa where we're going to get the color change that we're looking for. I'm Smath, real brief lesson on indicators. I hope this helped.